The following is Summer 2009 Math 263 Test 3 number 7. Consider a solid in the first quadrant bounded by y equals to x squared and z squared plus x squared equals 2. Part A. Sketch and write the equation of the projection of the solid onto xy plane, xz plane, and I believe yz plane here. Now let's start with the xy plane. Xy plane, it will be this one, y equals to x squared. Approximately something looks like this. Okay, now the problem is it is a solid and I don't know where to stop here. Let me leave it like that for now, and we will take a look on the other one. For the xz plane, it's follow this one, z squared plus x squared equals 2. Now that's actually part of a circle with radius radical 2. Now this is not a perfect nice one. Radical 2 here. Okay, now and then on the yc plane, you see we don't have the one relating those two, but we can see that y equals to x squared and z squared plus x squared equals to 2. So if I do substitution, I get z squared plus y equals to 2, or y equals 2 minus z squared. Okay, so means the vertex will be 2, 0, right? And we are dealing with the first octant only. You will see this is what it looks like. Approximately that's what it looks like, the first octant. So our issue is actually on the xy plane here. Is it bounded on this side or that side? No. To imagine that, let's try to graph that in 3 dimensions. Let's say this is my xyz, okay, and the xy, this is what it looks like. Okay, on the xz, on the xc, it is part of a cylinder, z squared plus x squared. Okay, if I do with and with the radius radical 2, right? So if this is part of the cylinder in the first octant, this is radical 2 here, this is radical 2. So you can see that because it is cylinder, it cuts this way. Okay, let me do the shadowing. Hope you can see that this is what it looks like. Now then, the problem is what is the intersection here? We know the x equals to radical 2, and at that point the z equals to 0, right? But what is the y? Okay, now if you think about that, we already did it here. Now the y will be 2, and the shadow of that will be following 2 minus z squared, y equals to 2 minus z squared. Okay, so maybe something looks like this. Okay, okay, now so if we look back, the solid will be bounded by this one here, and this is the curve in the air. Something always hard to graph. I wonder if I make it this way, it will be better. Okay. Consider this like a curtain, a shower curtain. Okay, then if we go back here, notice that and this is now bounded this way, right? If you compare that, let me put it back here on the xy plane. This is radical 2. Is okay? It's radical 2. And what else? Oh, this is radical 2 as well. Okay, now then the projection of the solid will be this part here for the xy plane, and for the xz plane will be this part here, and likewise for the yz plane will be this part here. Now that's for 7a. The harder one, the triple integrals. Part B, write 6 different triple integrals that give the volume of the solid. We don't need to compute, but we need to express them. Now the first one, the f will be 1, right, because that's the volume. Let me put dz, dy, dx. That's my first one. Let's write all 6 first. dz, dx, dy, and then dy, dz, dx, dy, dx, dz, and the last one is dx, dz, dy, dx, dy, dz. Okay, now let's start from the first one. Here dx will be from 0 to radical 2, y will be from 0 to x squared, right? We are looking at this one here, and the z will be, you see, if I pick a point here and I go up, I will hit the z, which is from 0 to square root of 2 minus x squared. Is it okay? Now for the second one, we basically reverse the ordering there, but the dc will be the same, 0 to square root of 2 minus x squared. Now the dy will be, oh, what is this here? What is that? When x equals to radical 2, the y equals to 2. Yeah, I think that is being confirmed here, right? When x equals to radical 2, the y is 2. Okay, so the y will be from 0 to 2, and then the x will be from square of x up to radical 2. Okay, now let's see the middle one, in which the domain, the outer two integrals, is the xz plane. The x will be from 0 to radical 2, and the z will be from 0 to square root of 2 minus x squared, and the y will be from 0 to x squared. Right? Let's see, imagine the one here. If I pick a point on the xz plane, then I will start from 0 and I shoot into the y direction. I will hit the curtain there, which is defined by y equals to x squared. Now then, if I reverse the ordering, still dy, so this will be 0 to x squared, right? And dx, dz, the z will be from 0 to radical 2, dx will be from 0 to radical 2 minus z squared this time. Okay, if you think about it, this is where I get it from. Now lastly, triple integral dx dz dy. So I will be looking at this, the part there. This is from 0 to 2, and then the z will be from 0 to so for z, square root of 2 minus y, right? And then the x will be from 0 to the square root of y. Oh, hold on, that's not right. Now if I pick a point here, and I go to the x direction, I will hit the curtain first and then I hit the cylinder, right? So no, it's not. It will be from the curtain, which is square root of y, to the cylinder. The cylinder will be square root of 2 minus z squared. Okay, it will hit the curtain first and then the cylinder. Now let's go further. Then the last triple integral, this z will be from 0 to radical 2, and the y will be from 0 to 2 minus y squared, and then the x will be from radical y to square root of 2 minus z squared. Okay, because I follow the one on the top. Now this is for summer 2009 Math 263 test 3 number 7.